So the Rhino file that's been provided for you, it's called Introduction Rhino 3D Command Table. So the idea for the command table is to take the most important commands in Rhino that you'll be using and compress them in a system that you'll be able to always go back to it and be able to remember commands and remember type of geometry required for these commands. Let's go to top view. So I'm going to double click on the name of the view, which is called perspective. Go to the top view and let's zoom in a little bit. So you're going to see that on the left side, we have name of type of the geometry that we're going to be working with, in this case, points, curves. And if you do find that your background color, in my case, I have a gradient view. If you do not like this, we can go ahead and change this. So for instance, in command line, I'm going to type gradient view and my color changes. I could type that again, it would go back to that view. I could also change the color of my layers here. So on the right side where you have your layers, you can see that we have one main layer called command table. Then we have 3 sub-layers. One is called text. So if I turn it on and off, you'll see that this is the text that we're seeing here. The other one is called frame. So this is how we're able to separate one command from the other. Then we have existing geometry. These are geometry required for us to apply these operations. So do go ahead and change the colors in a way that you think it would be better suited for you. For instance, I'm going to change the color of these grid lines to white. So all I need to do is to just click on the icon and make it a little bit brighter. I'm going to, instead of color of the geometry, keeping it a little bit dark blue, which blends in with the background, I'm going to go with the cyan color this way. So you guys can see this better, hopefully. We would also go ahead and change the color of the text. So instead of red, I'm going to go with a brighter color. In this case, I could custom select something like this so you guys can see this better. So any of these colors, you can adjust them. Now, we could see that on the left side, we have the type of geometry that you'll be working with. In this case, points, curves, surfaces. I want to pan down, so you can hold down your right mouse button and start to pan around. So after that, I have surfaces, I have poly surfaces, more than one surface, transformations, generation, mesh, etc. So today we're definitely going to try to get through as many of these as possible. If you zoom out, you'll see that the number of operations for curves is actually the most, because the way that we construct geometry, we go from point to curve, from curve to surface, from surface to a solid, etc. Right? So this is how we're building up. And since Rhino is a NURBS modeling program, curves operation in it is actually the most powerful. Therefore, we have quite a lot of operations for that. On the right side, I have my notes open. So if you do not see that, all you have to do is to type notes, and you're going to have a panel called notes. This way you can start to take notes while we're doing on instructions. If you do not want that, you could right click on it and turn off notes. Check off notes. Any of these panels that you see on the right side, if you right click on them, you would go to the user interface area and you can turn them on and off. For instance, I want to have the notes back. I'm going to click on that. So now I have another section for notes. I'm going to go to layers, and any of these tabs, you can move their location around and adjust them however you want. All right. So the next thing I'm going to do, because we're going to be building geometry over what we already have, I'm going to go to my layers and I'm going to lock the layer called frame. So just click on the lock icon. So then this way we're not going to be moving things around. I'm also going to be locking text. So this way that always remains there and we don't not modify it. So I lock text, I lock frame, and I do want to create a new layer. So then this way, the existing geometry would remain on this layer, but we're going to have a new layer where we can create new geometry. So we're going to go to the icon on the upper left side where it says new layer. And let's call this new geometry. And I'm going to change the color of this to something that really stands out. I'm going to go with a warm color. And if we do not like this along the way, I can always go back and change that. Once you have your new layer, I'm going to double click on it, and that's going to become the active layer. Okay, so let's zoom in on the upper left corner where it says points. And this box area that you have designated here, we're going to always just create geometry within this. So then by the time you're done with this exercise, you're going to have all the examples, and you can go back to each box and remember what was the command and what did it produce. So the very first one, which is called point, as you can imagine, this is what we went through over yesterday. You create a single point. So let's give that a try. I'm going to type point, enter, and then your cursor turns to an active point icon, so you can place this wherever you want. We also saw that the command point only allows you to create one point at a time. However, if you right-click or enter, the command will become activated again, and you'll be able to repeat this multiple times. On the lower area here, we have information about our C-plane or the construction plane all the way to the left here. Then we have position of our cursor, we have our units, currently we are in inches. Then we have the active layer. Then we have series of snap options, or options that would allow us to navigate the environment better. So let's make sure that your OSNAP option, which stands for Object Snap, is on. And let's set up series of snaps that we want to be working with. So for now, I do have End Snap activated. Near, I highly recommend you do not have Near Snap active, because basically you're going to be overwriting accuracy, right? So Near Snap, you're only going to be using if what you're doing maybe doesn't need to be precise, or really nothing else really works. But please don't use it as much as possible. We're going to have our point snap on, we're going to have the midpoint on, center on, intersect on, perpendicular on, and that's about it. So end, point, mid, center, intersect, perpendicular. So what this allows us to do is, if I type point this time, now my cursor will start to snap to the ends, but also to the intersections of where my curves are in this case, right? So you can also start to place points at intersections, at ends, etc. Okay, let's move on to the second command, points. So I'm going to pan around. So I'm going to hold down my right mouse button and pan around and go to points. So the command points, as you can imagine, is the plural version of point, and it allows you to non-stop place points wherever you want. And if we read what the command line tells us, location of point object, this is what we're placing, and then press enter when done. So as discussed yesterday, your placement of points could be either randomly, it could be based on a series of snaps that we have activated, or we can also input coordinates. So for instance, I could start to say that, in this case, let's say I want to do one at 0, 1, 0. So we see that one placed there. Or let's say I could do another one at the origin. Origin is 0, 0, 0. But when you're repeating the same number 3 times, you can only enter it once. So now that's the point that's placed. Now, even though I'm entering coordinates in this case, but you can see that my command is still active. So I could keep placing points until I'm happy with what I have. And then when I'm done with the command, I can do escape or enter, and we're going to come out of this command. Any questions so far? Yes. So type points, enter, and click, click, click. And then when you're done, right click or enter, and you come out of the command. Okay, so far we're looking at how to produce points based on coordinates. And as I mentioned yesterday, you can either use the command line, which is what this example allows you to do, or you can go through your menu options. For instance, under curve, this is where we have our point operations hidden, or in our standard menu here, on the left side, this is our standard toolbar. So this is where we'll be able to also do the same operation. So for instance, the icon of the point, which is on the upper right corner of this tool set, if you hover over it, it's going to tell you that if you do left click, you're going to be placing single point. If you do right click, you can do multiple points. So if I do right click here, again, I'm going to be able to set up series of points and then right click or enter when I'm done. So let's say you import a drawing and there's a series of intersections that you want to place. And once we get into the grasshopper, you'll see that often you'll be placing a point in Rhino and you'll be referencing them. So it's something that you would come across. So these could be construction points, reference points, and instead of repeating the same command over and over again, you would be just placing them at an intersection or wherever you want. So that would be placing it based on coordinates or along here. Let's say I have these series of grids that I have drawn. I'm going to do points, and I'm just going to start to place a point wherever I have these intersections, right? Right. So that would be using an array. That's something that we're going to get to in a bit. So you can have one point and you can create an array of points. I'm going to escape out of this. So it is a good question. Sometimes you would be using points to then set up, let's say, guidelines, but sometimes you would have a geometry like this. So for instance, this is a curve that I've created. I want to divide it and have points anywhere that I have the divisions, right? So for instance, you draw a line and you want to be able to divide it to a series of segments. So that's where we're going to be using the command divide. So command divide could have two different outcomes. I could either, let's say, the idea is to divide, let's say, the length of this table into 5 segments. I could do this in two different ways. I can either divide and cut, or I can divide and mark, right? So where you mark, these could be the points that you're returning. So this is where you need to pay attention to the options that I'm describing along the way. And for the first time, we're going to actually divide and only leave a point where the intersections are. Then for the second time, we're going to use the same command, and we're going to divide and cut the lines into smaller segments. So the command is divide, enter, select the curve that you want to divide. This is the curve that we have selected. So always just read what is in the command line, right? Enter. Now it's asking me a number of segments. So by default, always it has the number that you're going to be working with. So in this case, let's say that I want to divide it into 4 segments. But before I do this, I'm going to pay attention to this option. It says split. Do you want to cut down your curve into segments? I'm going to click on the Boolean option and I'm going to tell it no. We're going to come back and do it with yes later, right? So split, no. Do you want to specify a length, right? Because you can divide and your input could be number of segments, or you can divide and you could say that to cut each segment into 1 foot intervals. Does that make sense? Right? Sometimes you have how many segments you want, and sometimes you have how many lengths you have. So in this case, I don't want to input the length. I just want to divide it into equal segments. So let's say we want to do 5 segments. Enter number 5, enter. So now we're going to have these curves divided into 5 segments. So this is where we have a point that is sitting where these intersections are. Should I repeat this? No? Okay. But actually we're going to repeat this command, but we're going to use another option. So the way we're going to do this, do Control Z. So your points disappear. We're going to use the same command, which is divide. Select the curve to divide. So just pay attention here. Rhino is quite smart in the sense that if you run the command first, if there's no object selected, it's going to ask you to select. But if I already have my object selected and then I input the command, it would bypass that, right? So the selection order doesn't really matter. Now, this time I still want to split it into 5 segments, but I want to literally cut down my curves. So this time for split, I'm going to say yes. And it already has 5 number, which remembers from the previous time, and we're gonna do enter. So now you'll see that we have our segments as broken elements. Let's repeat this one more time. Do Control Z, so it goes back to one continuous element. Now, remember yesterday we were introduced to a command called direction, which shows you how your curve is drawn. So in command line, type dir, enter, and it shows that the curve is drawn from right to left. So why does this matter? If I want to split a curve into a number of segments, and in this case, if I do specify length of each segment, the starting point of your cutting is going to become the start of your curve. So let's figure out how long this curve is. I'm going to escape, select your curve again. Let's go to Analyze and use the command length. Let's analyze length. So it's going to say that my length is 38.5 inches, right? So let's say I want to take this 38.5 and I want to split my curves into 5-inch intervals. So therefore, it's going to do 5, 5, 5. After the 7th one, we're going to have a little bit of extra left, right? So when you're cutting material, you're going to be left with a little bit of extra. I'm going to click out. I'm going to repeat the same command again, divide. Enter. Select the curve that you want to divide. Enter. This time I'm going to tell it split yes, but we're going to click on length. So when you click on length, it automatically returns the overall length, which we already calculated. Then it tells me what is the length of each segment, and then quickly it also shows me the direction of the curve. So even though we went through this process separately, I wanted us to review those steps, but actually this command does show all of that. So by default, if I don't enter anything, it's going to be 1 intervals, but in this case, we're going to enter 5, enter. So now it's going to start to split this into intervals of 5, and as you can imagine, the last one is going to be a little bit shorter, right? Because it starts from that end. So what if I want to start from the other end? Any idea how I'll do that? Exactly, so I would flip the curve, then I would start from the other end. So whatever your curve is from the beginning, that's how you're going to start to be cutting this. Any questions about this? Divide. So I'm going to do this again. So this is the same curve. I'm going to type divide, enter, split yes, length. And here we can tell it to what segment lengths we have. For instance, I'm going to do 7 this time, and it's going to start to cut this into segments. Yeah, it deleted the last one, yeah. But to be honest, for the most part, you are going to be using it, and this is just based on experience. When you do divide, usually you're going to do this no split, and you're going to be doing it with the points. This is one of the ways that you're creating guides, and then you're starting to build upon this. But again, it depends on how you're going to be using this. So in Grasshopper, there's separate components for these. So usually after it's very rare where you'll be doing this in Rhino. Once you learn Grasshopper, you'll be doing all of this in Grasshopper, because you can go back and say, well, I didn't want 5 segments, I wanted 6 segments. So you could quickly change that, versus here we have to always delete and go back and redo that. All right. So for the next one, we have to go through the perspective view. So double click on the name of the view, which is top, go to perspective view. Now, I do want to focus on this area, so the last element here. And remember, yesterday we looked at a few ways to doing zooming extends and doing zoom selected. So let's practice those. If I enter ZE, zoom extends, it's going to zoom out, and we're going to see the overall everything that we have in this view. Or if you select anything, let's say this last curve that I have, if we type ZS for zoom selected, you're going to be able to zoom to that specific object. All right, so if you look at what we have here, it's basically a curve that is in 3 dimensions, and you have a series of points that are floating up and floating down. This is very common when you're drawing, and if you're not careful, you're going to have things that are all over the place, floating around. And sometimes when you want to use points and lines for guides and constructions, you do want to begin to align them together. For instance, here I have a point, let's say this one, let's all be working with this one, that its X and Y position is correct, but I want to change it Z. I wanted Z to be aligning with this end. So this component set point would allow us to start to align things in either X, Y, or Z coordinates. So I recommend for the first one, you just look what I'm doing, and then we're going to do this together, because it has a series of steps that we need to follow. All right, so the command is set point, S-E-T point. What is the object that I want to transfer? So in this case, I want to take this single point, so that's the object that I have selected, enter right click when done. Then it has this pop-up window. It's asking me, which of these elements do you want to change? Do you want to change its X position, Y, or Z? I'm going to say I don't want to do X and Y, so I'm going to uncheck that. I just want to change its Z. So I uncheck X and Y, I keep the Z, and I'm going to press OK. Now it allows me to select where the point is. Sorry, let me repeat this. This is the object that I want to transfer. I want to change its Z, okay? And I'm gonna match the end. You can see as soon as I start to hover over the end, that point is starting to jump up there. You see that? So here I can either keep a copy of the point, so it would remain that, or not. So again, this is a Boolean operation I could do. I'm not gonna leave a copy. So this way you could see how it moved. So you can see now the same point, I'm going to match that specific Z. So it jumps up to the same level. So let's try it one more time. We're going to take all of these points and we're going to match the same Z. So type the command set point, S-E-T-P-T, set point. Then select all the points that we have around here, all the blue points. You can hold down Shift to select multiple. I have a total of 4 points selected, because this one is already matched. Enter. What is it I want to check? What is it I want to align? I don't want to do X and Y. I want to do the Z. Press OK. And then match it to where you want to move it to. I can also match it to down here or down here. So now all of these points went to the same Z. Should I repeat this one more time? So I'm going to do set point, enter, select objects to transform. Right now I'm going to select all of these points and I'm going to move them down. And then you do right click or enter. No. You're doing select all points. Set point, not select all, not select point. Set point, S-E-T. So just read here. This is the command, right? Set point. Cell point, it's going to select all the points, 173 points. That's not what we want. So set point. What is it you want to transfer? Select the point that you want to match to the X and Y. Let's say I'm also going to move this one, right click or enter. I'm going to not do the X and Y, I'm going to do the Z. Okay, and let's say now I'm going to move all of them down here. So they're all going to move to this end. So this is a command that's used quite a lot in the construction phase and not really, for geometry construction. Once you have things in different planes, you could begin to use this. Any questions about this? Yeah. So, okay, so C-plane or construction plane is, right now, we are using the world construction plane. So world construction plane is X and Y top. So if we type C-plane, enter, so you can begin to set up your construction plane. You can see that your cursor becomes a plane, right? So wherever you set this, so I can set it here. You see my coordinate move there, right? So if I type C-plane again, construction plane, here I could tell it to change it to world. World is the default. It's where the coordinates are X, Y, Z. So if I select point, then I'm going to say top. So then that moves it there. So world top is the default that Rhino has. But your construction plane could change. So for instance, I want to model something and my object is completely rotated. So you can align it based on the world XY or based on your object. We're going to get into C-planes as we become a little bit more advanced. For now, we're just assuming our world plane is our C-plane. All right, any other questions about points? Okay, so let's move on to the second line, which is curves. Yesterday, we saw a shortcut which allows us to also sometimes preview or hide this world grid that we're seeing. So if you remember, it's F7, or you have to hold down function F7. So this way we can turn on and off this grid. So for now, I'm going to turn off this grid. All right, so our next series here, under curves, we have a line. So a line is a type of curve. And as we go further, yesterday we talked about freeform curves and lines. Today I'm going to explain a little bit more deeper into what their differences are. So the command here is a line. In your command line, type line, enter. And it's asking for a start of line. So here we have 2 points here. So select one as the start point, the other one as the end point. So this is the most basic type of line where you have 2 points. You're using one as the start, one as the end. But here in the next series of boxes, we are looking at different ways that the same command, line, so you can see the first word here is line, then underneath I have the subcategory that you need to be selecting. So when you type line in this case, there's a series of selections here you could do. So if you look at these points, actually these are vertical points, so one above the other. So if you select the vertical option from here, it allows you to now draw a vertical line. In this case, we have 2 points, but what I could also do is I could start to draw a line and then just provide the length. So let's try that going up from the end point. So I'm going to run the same command again, line, and I'm going to click on vertical. I'm going to select the start point, and because this by default gives me the vector of drawing a line, I'm going to just provide an input here. Let's say 3, enter. So now that line is locked through 3. I'm going to click again. If you want to repeat this, we can do this multiple times. So let's type line again, select vertical, start of the line, we're going to type 3, and then you're going to right click, and that line is now locked through 3. So you can either use 2 points, or you can use a starting point, set the vertical, and now that's going to be locked to that direction, but with that amplitude. Any questions about this? Okay, so the next one is also a subcategory of the line option. So I'm going to type line again, and this is the option to do bisector. So a bisector line is basically an average line that you can draw between 2 lines. So if you select the option bisector, then it's asking for what is the first line. So I'm going to say the first one is from here to here, and you can see that as soon as I do this, so right now between the first line that I've set up, there's an average curve that is starting to be drawn, right? So I can then lock it here. So now that gives me the vector of directionality. After this point on, I could also input a length, let's say 5, and then I'm gonna right click. Wait, why did it not work? I'm going to do it one more time. I'm going to do bisector, start, the second one, so that locks, and I should be able to do that, double click, and that gives me that input again. Let me repeat this one more time. Line, enter, bisector. So in this time, I could take this line as the starting point, right? So wherever you start, that gives you the average between your cursor and that line. And this time, maybe I can lock it here. So that becomes the line in this case. I can input the number, let's say 6, and I'm going to just right click. Why is it not working? Bisector. There you go. That's locked. I'm going to input a number. And I'm going to left click actually. And then that gets locked there. Were you guys able to do this? All right. So the next one is a perpendicular line. So again, typing line again. Enter the perpendicular option, you select the starting point. So in this case, in our orthos, we should have the midpoint activated. So we can start from the midpoint, and then you're able to draw a perpendicular line from there. So you can see that wherever I want to click, now I'm always drawing a perpendicular line. Since we also have our intersect line activated, I'm going to actually connect to the intersect, so I have a perpendicular line drawn from this line to that line. I'm going to repeat this one more time. Line, enter, start of the line. It really doesn't matter where you select because you'll be able to move it around. So I'm going to select this end right now. Line, enter, perpendicular. I'm going to select this point. And this time I'm going to do a perpendicular line to this. Yeah. Yeah, at 7. Function of 7. Which line? Oh, you mean this line? Oh, okay. So in that, right, okay. So if we do it that way, then this doesn't work. So this one always works along your planar. Yeah, so if I want to do this perpendicularly, so I could do it this way. We also have a perpendicular snap on. So for instance, I'm going to draw another line and I'm going to move it up. So let's say I'm going to select this curve and I'm going to hold down Alt, and then drag this up. So now I'm going to have another curve up here. And I'm going to draw a line in this case. Just enter line. And I'm going to start from a point, let's say this intersection. So one of the snaps that we're going to be seeing is going to be perpendicular. You see that? Perpendicular. So if you don't have this perpendicular snap on, it wouldn't connect to that. But because I have the perpendicular on, now I can draw a perpendicular line up. Yeah, so the line perpendicular sub option only works on whatever plane, whatever C plane you have on. Otherwise, we can use the snap. Great question. Okay, so the line tangent, as you can imagine, it would allow us to extend based on a tangent. So we're gonna input line, enter. The option is tangent, start of the line. So right now you can see that it's snapping to the center. So the center option, if I turn that off, I'm not going to snap to the center. But if I do that, that always becomes primary. I'm going to turn on the center option. And imagine, even if it's a circle, ultimately circle is one continuous loop, right? So we should be able to also snap to the end or to the midpoint of the circle as well. And this way you're starting to draw from the tangent. And this way, actually, because I have the perpendicular on, I can start to go from a tangent to a perpendicular. I'm going to repeat this again, line with a tangent. And here we can start to go from a tangent as a perpendicular line. Again, from a tangent to a perpendicular line. All right, so the next command here is a polyline command. Yesterday we began to look at it. So this command is quite similar to the way that you would be using in AutoCAD. So let's enter the command polyline. And it's asking for a start of polyline. So we have series of points here. Earlier there was a question, why would you be needing multiple points? So this is one of the cases. I'm setting up a guide here. So start of the polyline, just start to click, and it doesn't really matter how you select them. So you can also either connect to a point, or if you want, you can start to connect to a snap option. And then at the end, if you want to close it, you can type C or click on close, and your polyline would be closed. Any questions about this? Should I repeat this? Yeah, so if I want to close the polyline, by the way, the icon for the polyline is right here, right? The second one, polyline. You just click, 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 and you see this close option. So after you have a few, you can type C because _C is highlighted, or you can click on that and you can close the polyline. All right, so this is where Rhino becomes interesting. So here we have a command called Polyline, and here we have a command called Curve. Yesterday, if you remember, we went to Curve under Freeform. We used the very first one, and I mentioned that make sure that your degree is set up to 3. You guys remember that? And nobody really asked me why, and I said, well, we'll explain this later. So right now we're going to get to this concept of degrees in NURBS geometry. So NURBS, which stands for non-uniform rational B-splines. So we are emphasizing on splines. So these degrees are characteristics of the splines that allow us to create one type of geometry versus the other. So let's see what this means. So it says curve 1 degree, which ultimately means a polyline. So let's see what that means. Type the command curve. So we know that this category, we're calling them curves. So curve is the bigger umbrella of geometry, right? And the first thing that it's asking is the degree. So instead of 3 degree, which is the default, enter 1, enter. And let's start to draw and see what type of curve it would tell us. Well, it's actually a polyline again. And the same option that we had before for closing, we can go ahead and do that. So a polyline is ultimately a 1 degree curve. It's a 1 degree curve because it's made out of line segments. And for a line segment to be able to change its form, all it needs is 1 point. So when you have a line, you have total of 2 points, right? Beginning and end, correct? And when you're moving one of the points, the whole shape of that line changes, right? Its all overall length changes. A polyline is made out of a series of lines. So all of these line segments, when you change one of its control points, its overall shape would change. What do I mean by that? So let's move a little bit away from our chart and let's go to the top view. And let's do a little bit of a drawing on the side. So let's start from a line again. Type the command line, enter, and just randomly select the start point, select an end point. Now we have a line. I'm going to change the color to slightly brighter so we can see this better. All right, is that better? Okay, so this is a line. It's made out of 2 points, start point and an end point. Select the curve and type a command called points on, enter. So you have the end control points activated. So this is something that we're going to be using quite a lot. We're going to turn on the points and turn off the control points. When you have the control points on, if you select any of them, you can start to move them around using your gumball. So make sure that your gumball option is activated. So once you start to move your curve around, then basically its overall property is activated. If I want to turn off the points at this point, I can escape. I can escape one more time. The point is now turned off. So this is something that we're going to be doing all the time to modify our geometry. So select your curve. Instead of typing points on, we can type P on and P off, points on and point off. So select this again, point on, and you'll be able to move any of these ends around. So a line is a 1-degree curve. So it's a type of curve, it's a 1-degree curve because it only requires 1 point for it to completely change its shape, its length. Does that make sense? So it's just based on how many points of influence it has. So a line is a 1-degree curve. If you select your curve and if you go to your properties, so select your curve, go to properties and expand details. This is also the list window that we would be seeing. So you also see that your degree of a curve is a 1-degree curve. So how did I get here? I selected the curve, went to properties, and then click on details. And here you'll see that it tells me that it's a 1-degree curve. I'm going to close this. Another way you can begin to figure out the degree of your curve is by selecting your curve and typing a command called rebuild. Rebuild, enter. So this rebuild window gives you property of your curve. So inside your parentheses, it tells you that this has 2 control points and it's a 1-degree curve. Let's cancel out of this. So because a polyline is ultimately made out of series of lines, then it inherits the same property. So if we type the command polyline, enter, we can start to also draw a polyline, then stop. If you select your polyline and in your properties, bring up the details window again. In this case, we actually don't have that information. But if we type the command rebuild, you'll see that it still tells me that my curve is a 1-degree curve. Again, because a polyline is made out of series of lines. And if you select the polyline and turn on the points, every single point that you move, it's going to change the geometry of that segment, right? So it becomes a local manipulation. I'm going to escape to turn off these points. Let's come back to our chart here, and we're going to continue. And step by step, we're going to see what happens to our curve when the degrees are starting to increase. So the second one, let's type the command curve again, enter. This time, instead of 1 degree, click on 1 degree and change this to 2 degree. And let's begin to draw. So for a 2-degree curve, you're starting to see that now we're beginning to go from a polyline to a geometry that is more curved. And anywhere that you click, it ultimately becomes a control point. So I'm going to right click. So I started where I clicked. Basically, my curve is beginning to go through these control points. Everybody was able to draw the 2-degree curve? Change the degree. So type curve, change the degree from 1 degree to 2 degree. Here, 2 degree. Type the command curve, change the degree to 2. Curve, enter, degree to enter, and then begin to draw, and you should see a curve instead of a polyline this time, correct? All right, so once your curve is drawn, select the curve and turn on the control points again, points on, and you'll see that this time instead of going through every single point where you have these are ultimately the control points, right? So a 2-degree curve is a curve that every segment requires 2 control points. So take a look at it here. So for this curve to be constructed, it requires 2 points. For this segment to be constructed, it requires 2 control points, 2 control points, 2 control points, right? So we're beginning to see that now. You're not really drawing your curve through the points, but we're starting to have a more curved geometry. So this is beginning of how NURBS geometry is constructed. 2-degree curves are also, they have a certain characteristics. They could start to apply a lot of control over the geometry. Let's go to the side where we were drawing our line and polyline. And let's select your polyline that we had. And let's type the command rebuild, enter. So this window is quite important. We're going to be using this quite a lot. Inside here where it says point count, this is how many points I clicked. So I clicked 8 times. So I could also increase number of rebuilding. So imagine you are adding more control points. I'm going to keep it the same, 8 points. But instead of keeping it a 1-degree curve, I'm going to change this to a 2-degree curve. And I'm going to press OK. So you can see that the same polyline converted back to a more loose-ended curve, right? So with the rebuild command, we can start to convert curves together. So as you are starting to rebuild your curves, you can start to have smoother and smoother objects. Or you can go back. So for instance, the same rebuild curve, I'm going to rebuild it again. And this time, instead of 2-degree, I'm going to move it back to a 1-degree curve. Okay. So now it becomes more of a polyline, right? So you can begin to convert your curves back and forth. Exactly. Where we clicked initially. So obviously, when I went back from 1 degree to a 2 degree back to 1 degree again, I lost resolution, right? But this is actually a game that you're going to be constantly playing with your geometry to make it smoother or closer to what you want ideally. All right, let's go forward. The next one is a curve that has 3 degrees. So let's type curve. Instead of 2 degrees, this time we're going to do 3 degrees. And as you can imagine, this time it's going to become a little bit more smoother. So here, you're beginning to draw a curvature that is actually smoother than 2 degrees. So as the numbers are starting to increase, your curvature is becoming smoother and smoother. So because a 3 degree, if I turn on the control points, it's smoother than a 2 degree, actually for every segment, there's 3 control points that are significant to the shape. So if I start to move them around, you could see that it's not, your geometry is not really going through these control points, but it's like when you're controlling a doll with series of strings, right? When you push one, all the other ones are also becoming to be affected. So they become really a more averaged out curve. So in the next box, we have a 5 degree curve. So as the degrees increase, your curve becomes smoother. So in Rhino, you can potentially go up to 7 or 9 degrees. But to be honest, most of the curves that you're going to be using, you have to stick to 3 degrees. Because 2 degree can have sometimes imperfections. And higher than 3 degrees, it becomes very, very average. So by default, all the curves that we're going to be drawing, it has 3 degrees. Okay. We're going to skip to the rectangle option. Any questions? No? All right, so we're going to go to the rectangle option. So here you can start to see the icon of a rectangle, or here I can type rectangle. And there's many different ways that we can draw a rectangle. The basic one that we can start to draw here, we can have 2 corners. So these are the boundaries. I can start from one corner to the other. Or if I type rectangle again, if I want to do a center rectangle, I could start to have a rectangle that's growing from the center, right? So in this case, I could say the length, let's say 2 values and height 3 values. So we can start to create also a rectangle this way. If I only have a starting point for the rectangle, let's say I only specify the first corner, and after this I can either provide the other corner, which is what I did, or I could provide length, let's say 5 and 6, right? So there's many different ways that you can draw the same rectangle. Either you specify the other corner, it's the center one, you specify width and height, or you specify a corner and you do length and height. So a polygon geometry, it could have many different sides. So if we type the command polygon, a polygon could have minimum of 3 sides and maximum of however many you want, right? So you need to have a minimum of 3 sides. And there's many different ways that we can use this polygon. So by default, it is starting from the center. So I'm just going to select one of the points. And while this is activated, also I can go back and change number of sides. Let's say I want to do a hexagon, and I can either enter its radius, or I can start to also snap to, let's say, another geometry. In this case, I want to snap to this corner, and you can start to draw your polygon. I'm going to repeat the command again. Polygon. In this case, I'm going to change it to maybe a 5-sided geometry. And this time, I'm going to enter the radius, let's say 3. And I'm going to then position it however I want. We can either snap or enter the radius. The next one is the same command, which is a polygon, but this time we can create a polygon star. To be honest, this is probably one of the commands that you're not going to be using a lot unless you're making a birthday card for somebody. So I'm going to do polygon. I'm going to select the star option. So you are starting from the outer end, and then once you have the outer end, and you're doing a star inside and outside. Yeah. So you can laser cut birthday cards for each other. All right, so the next command is actually one of the commands where Rhino becomes really great. Curve through points. So it's a long command, so as you can see, it's string one after the other. By the way, any of these commands, if you want to change any modifications, if you want to add node, right now they're locked, but if I unlock them, if you double click on them, you can start to add more description to them. So this is a text object that you could start to then change. I'm going to lock it again. So curve through point. As you begin to type, what's great about Rhino, it gives you the suggestions. So curve through point, enter, select points to build curve through. So basically you start to select them in whichever direction you want. And if you enter, it gives you an average curve through them. Here you can also set up the degree. So by default, it's 1 degree. I can do 3 degree, 5 degrees, so it's going to be more looser. Go back to 3 degree, and I can also make it close. Enter. So it takes your curves and it creates an average through them. Now the order of selection is based on how you're selecting it. So how these points are being placed in your selection. If you don't like the order of selection, we can do this manually. So I'm going to do another curve through point, and I'm going to start to select them in the order that I want. Now you can set up the order however you want. Any questions? All right, the next component here is a circle. So this is one of the ones that you're going to be using probably quite a lot. So the icon of a circle, we see it from in our menu option, the third one on the left side, or we can just type the command circle, enter. So by default, it is providing a center for your circle, or you can start to use 2 points or 3 points. So there's many different ways that you can create a circle. So if you're using the center of circle, I'm just going to use the center point, and here I can either provide a radius, a diameter, or I can snap to another object, right? So I'm actually going to snap to the second point that we have here. So we have a circle this way. Now select your circle and turn on the points. And we're going to see that actually for the first time, we are seeing two different types of control points. I'm going to see if this color is a little better. So we're seeing two types of control points. You guys see that? Some of them are outside, some of them are sitting on the curve, right? So let's try this. Take the control points along the edge and start to move them around. And you're going to see that wherever the points are sitting on your curve, there's a break in the continuity, right? So this is called a kink. So a kink is, imagine in your car, if somebody puts a lot of force, when you get into an accident, your surface breaks, right? So a kink is a break in the continuity. So actually, these kinks are another attribute of NURBS geometry. So not only you have control points that are sitting on or they're sitting outside, but you can have kink geometry that their position would be never, it would always be synced with the geometry. So let's do Control Z and turn your circle back to its original shape and escape. Then select your circle and type the command rebuild, enter. You're going to see that it tells you that your circle is actually, it has 8 control points. So it was 4 on the surface, 4 outside, but it tells me that my circle is a 2-degree curve. So earlier we looked at an example of a 2-degree curve as a curve that looks like this, which if we don't really know, it actually was quite similar to a 3-degree curve. But another characteristic of a 2-degree curve are curves that could also have kinks. So a circle and an ellipse, forms that have to keep their uniformity, right? So circle and ellipses, they need to keep their uniformity. These could be example of a 2-degree curve. So the same curve, if you turn on the points, remember what it looks like. So we have 4 points outside, 4 on the curve. I'm going to escape, select this again, type rebuild, enter. Now, instead of making it a 2-degree curve, let's make it a 3-degree curve. So keep the same number of points, 8, but instead of a 2-degree, make it into a 3-degree, enter. Now, if you turn on the control points, you can see that now this is completely different. All the control points are sitting outside. And now if I select any of them, these kinks are not there anymore, right? So it becomes a smooth surface or becomes a smooth curve. So 2-degree curves could have kinks, so they could have breaks, but a 3-degree curve is always smoother. So therefore, the default Rhino geometry is a 3-degree curve. I'm actually going to go back, and since this is already in the video, we're just going to keep this as a 2-degree curve. All right, at this point, let's save what you've already created. So go to File and press Save, or you can do Control S. Okay, so the next one is an ellipse, which is very similar to a circle. So let's type the command ellipse, enter. It's asking for a center. Let's say somewhere like this. It's asking for the x-axis. So I'm just gonna click on this end. And you can see that basically it's a circle that has 2 different values. So for any of these information, we can either snap to a corner, or we can provide a value, let's say 3 values. and then left click, and you have your ellipse. And then at any point, you can turn on the control points and you can begin to modify them. For instance, I can start to move them this way or that way, right? So depending on what you want to get out of them, you can rebuild them. And Control Z. All right, so creating a helix. So I'm going to go to our perspective view at this point. So if you cannot find where your helix is, approximately find the area, select and do ZS for zoom selected. And let's use the command helix. Enter start of axis. Anytime that it's asking for an axis, basically it's a line, right? So it needs to know around which. So here we have a line around. So I'm going to go from here to here. Then it's asking for start of the radius. By default, it has value 1. I'm going to say maybe 2. And so that has the first one locked. Here we can change its rotation, a number of turns. By default, this is 10. I could say 20. I'm going to enter. Pitch. It's the starting relationship of the spring to the start. So let's change this to, let's say, 2. So you can see that your turns are starting to become much larger. So I'm gonna just click out of this so your helix becomes fixed. So there's quite a lot of variables, right? So you can start to really start an axis, end an axis. You can set up a diameter or a radius. So I could say 4, so it becomes quite large. I could do another one. So you can start to change as you're going forward. Number of turns, I could say do 20 and just click out, so now that becomes fixed. Now, if you take this curve and turn on the points, this has just too many curves, right? So it's not one system anymore. So any of these you can start to manipulate on its own. Okay. So the problem again with something like this is that if you set it up once in Rhino, then it's difficult to modify it, versus once we get to Grasshopper, all of this you can easily modify. All right, I'm gonna skip helix around the curve, go to extend. For those of you that have worked with, let's say, AutoCAD, extend is a really useful one. So right now, I have a curve, I have this one, and this one, I want to continue until it meets here. Right now, they're not touching. So I'm gonna use the command extend, enter. You either need to select a boundary. So for instance, this will become my boundary. And I want to extend this curve. So it uses it as boundary and extends it, and it touches there. If you do not want to use a boundary, I'm going to do Control Z. I'm going to say extend. All you have to do is to provide a length for extending. So for instance, I'm going to say 2 values, and let's say I want to do this one, and this one, and this one, and this one. So you can start to then extend based on intervals, right? I can do this one more time. So there's 2 ways of extending. Either you have 2 geometry that they need to be touching. So for instance, this one, I wanted to come and extend and connect to this one. So I'm going to type extend, enter, select boundary of object. So this is going to be my boundary. Right click or enter, and this is what I want to be extending, right? So it touches that boundary. or I can just extend based on interval. So I can type the same command extend. I could say, here it says or extension length, I'm going to say 3 values, right? And then I'm going to say this end or this end, and you can keep adding the intervals however you want. It's a very useful command. We're going to be using it a lot. So the next two, filleting and chamfering, are very close to the way that you would be doing in AutoCAD. Is everybody familiar with the term fillet and chamfer? So you would be doing, basically, you would taking either straight corners or corners that are not connecting, and you would be connecting them together. So let's try this. Let's use the command fillet. Here we can provide a radius, join. Do we want to join them? Let's make sure this is set to yes. Do we want to trim it? Yes. And for the radius, let's set this up to something like 3. So it's a quite large radius. And then select first curve to fillet. Select the first one, the second one. So it provides a really nice curve and it connects them together. If I don't set up any of these options, trim and join, then that would not be the case. So I'm going to repeat this. If I do fillet and tell it, I'm going to do a little bit smaller radius, like to join, no, do not join, trim, no. So at this point, we know that basically when we're doing a command, we have to always pay attention to the options. Then when I do the filleting, so you can see that it provides a new segment, and this is something that you could remain, right? So it all depends on how you want to be using it. So you can either fillet open corners like this or close corners like this. So if I use the command fillet corners, so in this case, they would be all closed corners. Select poly curves, enter. So what is the radius? I'm going to do 1 radius, the default. So you can do series of them all together, right? So this is really good. Let's say you're doing a drawing and you can set it up multiple ones at the same time. Otherwise, you can do fillet 1 by 1, right? So you can set up different radiuses, etc. I'm going to try this one more time. The command is fillet corners. What is the polyline that I want to be using? So in this case, this one. What is the radius? I'm going to do a little bit smaller, like let's say 0.5, so you'll be able to do multiple at the same time. Chamfer is quite similar to idea of filleting. So chamfer, what is the first curve? What is the distances? Join, no, trim, yes. I'm going to tell it join, no, trim, no. First curve to chamfer, this is the first one. Second one, so it ultimately creates more of a straight segment. If I do Control Z and repeat the same command again for chamfering, here I could tell it to, for the distance, I'm going to do a little bit bigger, 2. Trim, I'm going to say yes, do trim and do join. So this way, you're going to be able to get this as a continuous segment, right? So the difference between fillet and chamfering is the type of geometry returns that you'll be having. So this is used quite a lot when you're designing details, obviously. Okay, so moving on to the next one. This is actually one of the commands that was recently introduced to Rhino, and it's quite fantastic because it takes what you'll be doing with the fillet with 0 degrees, and you can start to clean up your drawings quite a lot with this. Sometimes you're drawing, and let's say this is quite typical if you're tracing a plan, and maybe you have these corners that do not match. So the command is connect, and it would allow you to select 2 curves together and just quickly resolve the end, right? So this is a very good command for that. So basically you start to just fill in anywhere that your geometry is not touching. So I'm going to repeat this one more time. Yes, you could. So I'm going to do connect, and this time I'm going to actually join it, and the first one, second one, so you have these geometry that you're starting to create. So offset is a command that you're probably familiar with, right? So it allows you to take your curve, and based on its normal directionality, you're starting to create offsets. So these are distances set up from the geometry. Offset would work in 2D if your curve is 2D, and in 3D if your curve is 3D. So let's give this a try. For the first one, let's start from the straight line segment that we have. We're going to use the command offset. Inside, what is the distance of offsetting? I'm going to set this to be, let's say, 0.5. Enter. Do you want to do it from both sides? For now, I'm just going to keep it one side. And you select the curve that you want to offset. And you can start to, with your mouse, set up whether this offset is on one side or the other one. Wherever you keep your cursor, you'll be able to offset in that direction. Let's take this second curve, turn on the control point, so key on or F10. And you can see that there's actually quite a lot of control points on this curve, right? So these are control points. If I want to start to move this curve slightly higher, but these control points are too many. So we're going to actually rebuild it with less points. So select your curve, type rebuild, enter, and it tells me that by default it has 23 curves. I'm going to reduce this to, let's say, 10 points. We're going to keep the angle the same. And here you can see that it shows you the deviation. So when you're rebuilding it with less or more points, sometimes you have a deviation. In this case, it doesn't matter that deviation. We're going to press OK. Select, turn on the control point again. So now we have less control points we can work with. And then randomly select one or two of these points. And I'm going to just move it up with the gumball. So this way we're going to try what if we're trying to offset in 3D. Escape. Escape. Everybody was able to rebuild and move the geometry up. Tolerance is when you rebuild it with less points, there's a little bit of a change that your geometry might take, right? So if you remember earlier when we rebuilt this, the form slightly changed, right? So that will be the tolerance. So I'm gonna, okay, so just come back to this. If you're not able to zoom in on it, just select and do ZS. Zoom selected. Now let's try offsetting again. Type the command offset. And for distance, I'm going to keep it 0.5, but this time let's do both sides. Both sides. And select your curve and just enter anywhere because it's going to be from both sides. So you can see that you have your offset from both sides. So basically, it's not duplicating the curve 2 more times, but it's based on its normal vectors. So if you remember yesterday, we discussed that when you turn on the control points for a curve, you have this thing called a tangent vector, right? If you take each of these tangent vectors, and if you were to rotate it 90 degrees, this is going to be called normal vector. So therefore, for this curvature here, when we are offsetting outside, there's a little bit of an expansion versus if you were to offset this inside. Now for the circle, because it's a uniform shape, if I were to offset this inside or outside, we're not going to see that much difference except for scaling or geometry up and down. All right, the next three commands are where you can start to see really power of a program like Rhino. Because Rhino is really great not only in creating geometry, but also in filling in gaps. Whenever you don't have the geometry, it can actually start to construct the geometry for you. For instance, here I have two 3-degree curves that I'm constructing, and they're not touching together. And I later on want to connect these together and create a continuous surface. So the command is blend, enter. So what is the first curve? Just select one of the curves. What's the second one? And it creates this really nice in-between curve for you. Do this one more time. Command is blend. And the first one, the second one, so creates a really nice continuous curve for you. Yeah. Sorry, I cannot hear you. You mean select this one first, then the other one? This one? So let's try it. It will be the same thing. No, because these are too far apart, right? So it does give you that, but there's a lot of averaging that's going to happen in between. So this it basically takes, remember we have this thing called a tangent vector, right? So it takes this tangent vector and it takes this tangent vector and it's creating an average in between. So even though in theory it could draw this for you, so I could do this one as well, but it's a little bit more difficult to control this, right? So for instance, yeah, so it doesn't want to do it for this one. There's a breaking point for this. So, right, so in a sense, it is an average, but it might not be close to what you want, versus for this one, you're starting to really blend in two different curves together. We are able to also do the same thing for surfaces, which we're going to see a little bit further down. All right, the next one, this is absolutely one of my favorite commands because it's going to save you so many times. So I know you're currently in the process of doing these case studies, so there's a lot of drawing and redrawing together. So it's very common for you to start from a shape and you're drawing multiple layers together and you want to get, let's say, a shape in between. So let's say I have these 3 circles together, but what I really want is this area that they're intersecting, right? So for me to get there, I need to actually draw these and then cut these and then join them together, etc. But this command combines so many of these steps together. I recommend you look at what I'm doing first, and then we're going to repeat it together because it has quite a few steps together. So the command is curve boolean. Curve boolean. It's asking to select the curves, and then there's few options here. It's going to say delete input. I'm going to say all. Combine regions, yes. So basically, when I use these curves, it's going to delete it, and it's going to combine at the end. So see what I mean by this. So I'm going to select these 3 curves, enter, and I'm going to start to select areas that I want to keep, right? And then when I'm done, that's it. So it combines so many steps together. I'm going to do Control Z. Let's do this together. So the command is curve boolean. Curve boolean. Delete inputs. For now, let's say all. Combine regions. Let's say yes. So delete input all, combine regions, yes. Then select these 3 circles, right? And then do right click or enter. Then start to select the areas that you want to keep. Let's say I want to keep this. Then right click, and that's the area that you're left with. So it deletes everything that we initially started with, and it combines it together, so it becomes a polyline, not a segment. So let's do Control Z and look at the other options. Again, the command is curve boolean. Delete input, this time we're going to say only the ones that we use. Combine regions, no, don't combine the region. So use, combine regions, no. Select the curves you want to work with, right click or enter, and then start clicking. Let's say I want to select this. Once I'm done, right click. So you can see that it doesn't combine them. So these are just separate segments. And the ones that I didn't use, it keeps them as is. So it combines so many levels together. And this is really fantastic when you're doing drawings or construction setup. Do you guys want to try this? Spend like a minute trying different options here. So again, curve boolean. Select the curves. I'm going to say delete input all of them, combine regions, yes. And then you end up with the shape that you want. So definitely this is the ones that you want to remember. You're going to be using this so much, especially let's say if you're doing drawings and at the end you want to have a section line for all of it, or you want to have a cut line. So delete input all, combine regions. I'm going to say only the one that I'm using, combine regions, yes. And something like this. Any questions about this? All right. This next command is one of my other favorite ones. Now, does everybody see the back of their surfaces with a different color? Yes? So remember, this is a function that we set up yesterday. So if you select your surface and type the command dir, so wherever your arrows are going towards, that's the front of your surface. The back side is a different color. Now, keep in mind that this back face setting is something that's specific to the view. So currently, if I go to the name of the view, which is perspective, if I drop down the menu, we are in shaded view. If I go to ghosted view, which you start to see through, you might not have that option activated. Can you all try this? So if you go to ghosted view, if you look at back side of your face, that option doesn't exist, right? So let's go back to and also set up a color, but maybe a different color for the ghosted option. So if you remember yesterday, we go to tools, we go to options, you go all the way down to view, we extend this, we go to display mode. So that's tools, options, view, display mode. And this time, yesterday we set up shaded. This time we're going to be doing ghosted. Then option here, back face setting. We're going to open the menu and go to single color for all back faces. And I'm going to use another color which really stands out. Maybe this time, I don't know, maybe light green. Okay, so this command interpolated curve on surface. So we're starting to see how certain terms such as point is PT, curve is CRV, surface is SRF are starting to be abbreviated. So interpolated curve on surface is a command that would allow us to draw a line that follows the in this case, instead of a C-plane, which is world, it follows property of the surface. So this is used quite a lot. Let's say you have a site and you're drawing maybe a driveway on the site and you want your curve to be following a surface. So let's start to input this command, interpolated curve on surface. So as you're starting to type interpolated curve, then the second one will be interpolated curve on surface. And it's asking for a surface to draw on. So in this case, the surface that we have selected here would be the starting point. Then it's asking for start of curve. I'm going to start from, let's say, the middle point here. And you're going to see that now we're starting to draw not on XY plane, but we're starting to draw on the surface. So this is a very, very useful command that, in Rhino, it's quite easy to do. In any other program, you have to draw this and you have to project it on the surface, versus this time, we're just drawing on the curve. Any questions about this? All right. So with this, we're going to now move on to surfaces. So I recommend you save your file at this point. We're going to move on to surfaces. So the most basic kind of a surface that you could be constructing is a surface plane. So a plane is a surface that it has 3 to 4 sides. And to construct a plane, if we go to surface, you can see the very first thing that you see in the menu is called a plane. From a corner to corner, from 3 points, or vertical. But if we just use the command plane, enter, all of those options are also available. By default, we can construct a plane which is similar to a rectangle from one corner to the other. So we can start to draw from one corner to the other. So I dragged my surface from left to right. So we can see that my surface is actually, my color of the surface is very close to the color that I have. So I'm going to actually change the color of my layer to pink. This way we can see the front side and the back side. So when I constructed my plane, I went from left to right. So this is the front and back. What if I actually do it the other way? So I go from bottom to top. You can see that in this case, it doesn't really matter in terms of directionality of the surface. The next command here is surface from point. You can see that we have series of points set up. I have 4 points, and 2 of them are on XY plane, and 2 of these are higher. So the plane command, this is assuming that you're creating a surface that perhaps is using 2 boundaries, 2 edges, but surface from point, it requires minimum of 3 to 4 points. So S or F for surface PT. Here we can start to draw a surface. I'm going this way counterclockwise. So this is my surface right now. So this command, surface from point, you can also apply it to 3 points, but the last one you just have to repeat itself. So it becomes a triangle. I could repeat it one more time. And the last one you just have to close itself. So you can also use it this way. Now, these surfaces that we're creating, if you select your surface, let's say the planar surface, and if we turn on the control points on, you're going to notice that actually control points are not specific to curves, but also for our surfaces as well. So using them, when you have the control points on, you can turn them on and off. I'm going to do a Control Z and escape to turn them off. You would also see that the same command rebuild would also apply to surfaces. So if I type the command rebuild, by default, it tells me that I have 2 control points in the U direction, 2 control points in the V direction. So do you guys know what a U and a V direction is? Okay, so X and Y and Z, these are ways that we can define, let's say, points or coordinates in Euclidean space, right? So a point could have X, Y, Z. But a surface, it has other properties called U and V, and if we have thickness, we have W. So why do we need this? Let's say I have this table and I measure the width and length of this table, and the width and length, the way that I define it in this room will be same as if I were to take it outside of this room and define it, right? So this table, if I want to talk about, let's say, that specific point on this table, I can talk about it in two different ways. Let's assume that that corner is our world 0, 0, 0, right? So I can define this point based on the relationship to 0, 0, 0. So I can say this is the x, this is the y, this is the z, or I can define this point based on relationship to this table. So in that case, the relationship of this point to this table would not change whether I have the table in this room or in any other room, right? But the coordinates of that point would change whether this table is closer to there or further away. Does that make sense? So there are relative coordinates for a surface, which we define them as u and v and w if we have thickness. And there's world coordinates, which are x and y and z, which always is calculated towards the origin. So working with u and v allows us to look at a surface as a two-dimensional domain. So what is a domain? Domain is something that has a start and an end, right? So if I have a surface, let's say if this is my surface, this could be the start. And I could say this is my u direction, this is my v direction, this is 0, and that is u and v, right? So that becomes a way for us to then define a surface. So what this tells me when I want to rebuild the surface is that in u direction, I have 2 points, right? Because this is a planar surface. I can start to rebuild my surface. So instead of 2 counts, I could have maybe 3 and 3. Press OK. Now, if I turn on my surface, do you see there's more control points along the surface? Before I only had these corner points, right? So I can start to then select any of these points and I can start to move it up, and you can see that my surface is starting to change its shape. So this is very similar to the way that when we have a line or when we have a polyline, there's only so much movement that you can have. But when you turn to your curve to a 3-degree curve, or when you have more control points, there's more relationships that you can manipulate that way. So similar to our curves, our surfaces could also be rebuilt. Should I try this one more time? Rebuilding this curve, all right? So I'm going to start from this one more time, right? So I'm going back to plane, and I'm going to use the command which is plane, and I'm going from a corner to a corner, right? So this is a rectangular surface, right? So meaning if I were to turn this on, and I'm actually going to turn off the points so we're not distracted by those points. So I just turned off the point here. So if I were to select the surface and turn on the control points, I have 4 corners, right? Correct? And it's only 4 corners, meaning on this edge, I have 2 control points. On this edge, I have 2 control points, correct? So there's only so much movement that the surface can have. So for instance, if I turn on the control points and I move up one of the corners, it would become a shape like this, right? So it only has 4 points it could play with. But if I want the surface to be smoother, if I wanted to have more control points, all I need to do is to use the rebuild command. So I'm going to select it and type rebuild, enter. And it always tells me how many control points I have. In U direction, I have 2. In V direction, I have V. How do I know the U and V direction? When your surface is activated like this, red, which is also corresponding to X, it always is the U direction, and green, which is always corresponding to Y, not in terms of orientation, but in terms of relationship. So primary, secondary, this is the V direction. So I can change this. I can say, give me 3 divisions in U direction and maybe 4 divisions in V direction. So when I turn on the control points again, you're going to see that I'm going to have different counts. So now when you have more control points, you can start to manipulate your surface more. So similar to the way that we had our 3-degree curves, now we're starting to have more variations here. And because this is a NURBS geometry, all of these networks, that is kind of, imagine it's encompassing your surface. When I'm changing one, this is a 3-degree surface, 2 other points are also being affected. We're going to talk about this repeatedly as we go through Grasshopper, and get more advanced in Rhino, so hopefully it would become less and less abstract for you guys. Any other questions? All right, so we're going to skip to here. I'm going to turn back the geometry here. So in Rhino, when you are making a surface, you at least need to have 4 sides or 3 sides for you to create a surface. So therefore, if I want to create a shape that is, imagine a surface that's filling all of this geometry doesn't exist. So this is a too complex of a geometry. So what Rhino is going to do is going to create a straight surface, which is a little bit outside of this boundary. Then it's going to trim it based on this boundary. So a surface like this, for instance, when I'm creating a planar surface or from 4 points, this is called an untrimmed surface. So it's not cut down anymore. But this one, because it needs to create a regular surface, then trim it down, this is going to be called a trimmed surface. So what do I mean by this? So the command is called Planar Surf. So a planar surface. Select planar curves to build surface. So select all of these curves, right click. So now you can see it creates a surface between them. What does it mean when we have a planar geometry? What's a planar surface or a planar curve? What's a plane? Yeah, so it's basically a directionality, right? So a planar surface or a planar curve, it means all of their control points are on the same plane. It doesn't all have to be top down, right? It could be rotated, but they all have to be on the same plane. So if they're not, then this cannot be created. But check this out. If I select the surface, do you see how it has this strange line going through them? And if I turn on the control points, actually control points are going to be sitting outside. Because what Rhino did, it created this surface first, and then it actually trimmed it down, right? So this is right now a trimmed surface. So do we need to care about that right now? Not really, but eventually when we're creating more complex geometry, some operations you cannot do with the trim surface. So this is something that just keep in the back of your head. Then we're eventually gonna, once we face it, there's ways that we can fix this. Any questions so far? Good. All right, so next thing we're gonna do is we're gonna look at the concept of lofting. So yesterday when we were looking at the concept of explicit history and how Grasshopper was introduced to us, we looked at quickly concept of lofting. And here we're going to look at not only concept of lofting, but a few different ways that lofting options would allow us to have different surface types. So the main command is called Loft. And if you look at these curves that we have set up for you, if you select all 4 of them, and type the command dir, they're all going in the same direction. So if they're all not going in the same direction, then what you're going to end up with is something called a twisted surface. So your surface is going to go from one side to the other. So I'm going to escape, and we're going to begin by using the command called Loft. It's asking for select curves to loft. So you begin to select them one by one. And you need to pay attention that you're selecting them from the same end. Right click. So right now I selected from this side, my surface is facing backwards. That's not a problem. What we mean by normal lofting is the option that you select here. So normal lofting, it takes the average position of your curves and it tries to give you a surface that is a really nice average between them. So for now, I'm going to tell it to keep it as a normal lofting. If I want it to be a closed loft, if I check this box and do a preview, it actually takes the last element and it closes it. It's difficult to see that because right now it's actually twisting on itself. So I'm going to uncheck that and press OK. So now I have a surface that goes through all of these curves. Now I'm going to redo this and take a look at what happens if I'm not careful how I'm selecting these curves. I'm going to type loft again, enter, and see I'm selecting one from this side, one from the other side, from this side, right click. You guys see how it's twisted here? Yeah, so you have this like bow tie option because I was not careful how I selected these. So in Rhino, the way that you select your elements determines how you are lofting this. In Grasshopper, we're not going to have this issue because as long as the directionality is the same, we would not have that issue. So I'm going to escape and Control Z. And we're going to loft again, and this time we're going to select them all from the right direction. So this time I selected them from this end. My surface is now facing up. Is everybody able to loft? Mm-hmm.
What's the meaning of split as a tag?
What?
Split as a tag.
Is it part of the options of lofting?
Yes.
Okay, let me see. Which one? Split and tangents. So in this case, we don't have a tangent. So right now, this is actually a continuous curve. But if I have multiple curves that they were not continuous split at tangents, it would cut your surface into a series of segments. So for now, we're just going to keep it as is. I can also rebuild my surface with more control points. So this is if you have, let's say, curves that don't have the same. We're going to get to this later on. For now, don't worry about it. So just all you have to worry about is just selecting the normal loft and press OK. So when you look at normal loft, you can see that it's quite nice. It goes through all the curves and it gives you a nice surface. But sometimes you don't want your surface to go through all the curves. You want more of an average option. So that's when we would do loose lofting. So we're going to go back to loft again. Select curves to loft. I'm going to select them in the same order that I have. But this time, instead of normal, I'm going to select loose. Press OK. So you can see that it's actually creating a more of an average. So there's less going up and down, and it creates like it kind of favors the surface more than that favors the curve. So all of these options allow us to go through a different variation. The next one, loft straight sections. This is one of the ones that could be quite useful. I'm going to select all of them in the order that I want them to be lofted. But instead of loose lofting, I'm going to do straight sections. So you're going to see that it actually breaks your surface, right? So this one creates a continuous surface, but it's favoring the curve. This one completely treats it as a series of separate elements. So pay attention here. When I'm doing a normal lofting, I have a surface. This one creates a surface. But when I'm creating my straight lofting, it's returning a poly surface, multiple surfaces. So what it does, it lofts between two and it stops. So it favors your curves more than it favors the surface. So therefore, this becomes ultimately 3 segments connected together. So everybody has the straight segments. Yeah. So select this straight segments, and we're going to use a command called explode. Explode, enter. So what explode does, it actually breaks your curve into series of segments. Sorry, it breaks your surface into series of segments. But you wouldn't be able to explode a surface because surface is just one object, right? So the concept of exploding doesn't exist because it's a single surface. But when you have a poly surface, multiple surfaces, then you're able to explode. Now, the opposite of exploding is joining. So explode is when you take it apart into multiple segments. Joining is when you connect them together. So if I select these surfaces together again, if I use join, now it tells me that it went back to being one poly surface again. So the idea of exploding and joining also exists when we are working with curves. So if you remember earlier, we had drawn a single curve and we had a polyline on the side, on this side. So you can take a polyline and you can use the same concept called explode, and your polyline would turn into a series of curves. And then you can select your series of curves and use join again, and it's going to turn into one geometry. So basically, a lot of operations between curves and surfaces are the same. So you can join or you can explode. All right, any questions so far? Right. So I'm going to skip this other lofting option. We're going to go to sweeping. So sometimes you have series of segments like this. So these are profiles that you'll be connecting and you'll be creating a surface. But sometimes you have another type of curves that you want to use to create a surface. So for instance, concept of sweeping. So this is similar to for you when you are maybe a stair railing that you have, and you have a profile that you want to then continuously use to create a surface. So the concept of sweeping is something that is kind of broken down into two options, sweep 1 and sweep 2. And that is just based on how many reference points you are going to be able to set up. So concept of sweep 1, if we type sweep 1, enter, it's using a rail curve. So in this case, our rail is this continuous curve that I have. That is asking for a cross-section curve or curves. So in this case, this profile that we have is going to be the cross-section. Right-click or enter, and then drag seam point to adjust. So seam is always the beginning of your curve. How are you drawing this? For now, I'm not going to do anything. I'm just going to press enter. And similar to the lofting option, it also gives me these different ways of creating my surface. So freeform is the one that is actually favoring the surface more, versus road-like top. All of this, you can do a preview. You can see that your surface is starting to twist a little bit. So you're starting to see how one is starting to favor the curve more versus is starting to favor the surface more. I'm just going to go with the default. Now I have a surface created based on this profile, but it's going along a curve. Should I repeat this? So you can take any shape and you can sweep it along a rail. Now in this case, I only have one rail. So when you have one rail, pretty much whatever that curve does, your geometry goes along there. But with sweep 2, we can start to introduce more than one rails. So with sweep 2, in this case, I have a rail along here and along here, and you can see these are starting to get wider as we're going down this way. So with sweep 2, I'm going to be able to have more control over geometry. So I'm going to say sweep 2. It's asking for a rail. So in this case, this is the first rail. Sorry, I did sweep 1. Sweep 2. First rail, second rail, right? So either one of these. And then what is the cross section? Similar to what we did before, enter, enter. So now you can see that actually our geometry is more favoring the rail. So the same profile, this one it became continuous versus this one, it's starting to get wider and narrower with the curve that we're starting to create. Now at any point, if I want to change the directionality of my surface, I can just select the surface and just type flip, flip, it would change the directionality of the surface. So same with this one, select your poly surface and flip. We're going to skip the second one because it's basically sweep 2 but with multiple rails. We're going to go to Revolve. And Revolve is used quite a lot when you're doing shapes that have the same form that is going along in axes. It's really good for designing something like a doorknob. So let's use the command Revolve. Enter. What is the curve that we want to revolve? Well, in this case, this is this weird profile that we have drawn here. Right click and enter. And what is the axis for revolving? So the axis is this line that we have here. So we want to evolve from here to here. And you can see that it's starting to create this kind of circular motion. And it's asking us, what is the start angle? So here I'm going to just input 360. So you can start to see that it is starting to revolve. And I'm just going to enter. And it gives you this 360-degree shape. I'm going to repeat this one more time. Revolve. Enter. What is the curve that you want to revolve? Well, this is this profile that we have. Enter. What is start of revolve axis? It's this one. That's the end. Then what is the start angle? I could say the start angle is, in this case, 0. What is the end angle is 360. So it's a full revolve. So it gives you this. I could do half revolve, right? I could do 0 to 180. Any questions so far? All right, so the next one is using a scenario where earlier we had a series of curves that were planar and we were creating a surface between them. But what if they're not planar? So here we have a curve that's on the XY plane, and then we have these two arcs, and I want to create a surface between them. So this command, which is called network surf or network surface, works when we are trying to create a surface between 3 to 4 line segments that are maybe not planar. So let's use the command network surf. Network surf. Select curves in network. So you're just going to select them in any order you want. Right click or enter. So it assigns an A, B, C based on the position, based on however many you have. You can see that we can go all the way up to D. So you can have 4 of these. And we can here do a preview so you can see how it's starting to favor this. Here I can tell it to do a loose lofting between them. I'm going to update the preview, so not that much different. I always go with the position option, so it tries to keep them as close as possible to the edge, and then press OK. So this is one of the best ways that you can go and create a surface between curves like this. And again, you can flip them. Okay, so the next series would allow us to work with only single line or two lines and create surfaces based on that. So the concept of an extruding a curve is one that we're going to be using quite a lot. So you draw a profile and you want to go and create a surface based on the same profile but along X, Y, or Z axes. So the command is extrude curve, select curves to extrude. So we're going to select this one single curve, right click or enter, and by default, you're going to be seeing a curve, a surface that's coming out of this. Do you guys see single or double? Do you see it coming out from both sides or one side? One? Okay, so I have this option both sides on from previous option. That's why it's doing this. So this way I could drag and place it either one way or the other, or I can do both sides. Or I could provide a value. Let's say I could do 5. So it's going to create a surface that comes out of it that much. Or I'm going to do Control Z. I'm going to do this command again, extrude surface. Start curves to, or select curves to extrude. Here, I could set up a direction for it. So I'm going to do one side. What is a direction? Direction is a vector, right? So I'm going to say direction. What is the start? I'm going to say, let's say from here to here. So you can see that it's starting to lock my surface to a certain direction, right? So this could be a reference that you have in your environment. And once you have the vector lock, I could say 5 values. Let's try this. Again, extrude, curve, select curve to extrude, and then set up a direction. And this could be just a vector that you're setting up. Maybe it goes from here to here, and you're starting to move your surface in one way or the other. And I could say go, let's say 5 values, or go -5 values, right? So you can do positive or negative values. Is this clear? Or the same command, in this case, instead of extending the same profile, here I can use another guide profile this way. So I have one profile, and then I'm using another one that's going to become a guide. Ultimately, this is very similar to the sweep one command, right? I have a rail, and I have a profile that I want to go along. So we're going to type extrude curve, but in this case, extrude curve along a curve. It's a long command, extrude a curve along a curve. And select one of the curves to extrude, then select the path. And basically it takes the two and it creates a nice average between them. Everybody was able to do that? Again, extrude curve along a curve. What is it you want to extrude? It doesn't matter which one I select. Right click. Then what is the path? So you have the surface created. So no other program would allow you to play with this many ways of creating a surface, right? So Rhino is really great in that sense. So earlier we looked at concept of extending. This is where we were extending our curves out. We can also begin to extend our surfaces. So it's ultimately using the tangent vector and it's extending our surfaces. So the same command, usually without anything, is applying to curves, but when it has the term surface, then you're applying to surfaces. So extend surf. What is the edge of surface to extend? Select an edge, and you can say how much to extend. I'm going to say 4, so it's starting to extend that way, right? So again, select the edge, and I'm going to say 3, so you're starting to extend that way. Any questions? Okay, then the concept of offsetting, which we looked at here, where you take a normal of a curve and you're starting to offset based on that, could also be applied to surfaces. So offset a surface, offset surf, you're selecting the surface or the poly surface, so single or multiple, and it's always based on the normals, right? So here you could see that it's the normal of the surface. Do I want to do it from both sides? Perhaps, yes. And I can provide a value, let's say 2 values, and I'm starting to offset. So basically, in this case, it's providing a solid. If you guys don't see the solid, this is an option that we have to check. So if you don't have the solid option on, what it would provide is basically 2 surfaces that going up and down. So this is a really, really great way for you after you have created a surface. Let's say if you want to 3D print it with a little bit of a thickness, this is the command that usually it works really well. So you would create a solid, yes, you can do one side or both sides, and you provide a value, let's say 3 values, and it creates a surface. Now, because this is offsetting, so it's continuing the directionality of the normals, so therefore you're going to see your surface expanding, right? Or compressing a little bit. So similar to the blend option that we were looking at, which is starting to blend two curves together, we can also begin to blend surfaces. Is everybody caught up here? Yeah. So the concept of blending surface is very similar to the way you would be doing the curves. It's basically extend and merge. So if we use the command blend surf, here we would be selecting one side of a surface, second side of a surface, right click. And guys, pay attention here. What's really nice about this command, while you are trying to do it, you can start to modify and decide how much weight each side could have, right? Because you can start to favor one side over the other and then create your surface between them. So I'm going to do this one more time. That is blend surf. Here, this edge and that edge, right click. Here, you can start to modify how you're trying to modify this. By default, usually it's the curvature, and you can start to see how by ultimately changing the tangency and the way these are starting to merge together, you can start to have different outcomes, right? So this is a quite powerful command in that sense. Any questions? Yeah, so connecting is for curve. So in this case, so blending is quite similar to what the blend option gives you this. Oh, okay, so that's a different command. Yeah. So let me finish this, then I can talk about that command. All right. So blend surface and blend work quite similarly. It basically takes the tangency and merges them together. Now, so far we looked at pretty much everything that you would be needing when you're working with one single surface. And sometimes you have geometry that are maybe not set up in a way that would work with network surf or planar surf. For instance, you are creating a drawing and it has like all this difference. So if you look at what this patch has, do you guys see how there's all these curves that are going up and down, and then maybe you have a point up here, and patching is usually the last resort. When no other command works, patching would give you an average surface between geometry. So, for instance, here, using these points and these curves that are going up and down, and they're not connected, we're going to create an average surface. This is used quite a lot. Let's say if you have a site area that you need to resolve, but it's not really a clean surface, you can always patch it. So we're going to do patch, enter. Now here we can use curves, points, point clouds, all kinds of different things. So all you have to do is to just select all of these elements, right click, and press OK. So you can see that it gives you an average surface based on all of this. So if nothing else works, you can use patching. But what becomes difficult with patching, right now, if you zoom in and look at your edges are not going to be perfect. So if you have a patch surface and if you have another clean surface along the edge, these might not be merging together.